Now about your practical exercise. In this practical exercise there are quite a lot of instructions to do, but you will see that most of these instructions are quite easy to fulfill. And if you want some backstory about this exercise, then backstory could be something like system we are using here for this traffic management system needs to be extended because business of company is extended. And we need to introduce more different roads. These actually should be roads in general business meaning, not roads. To have roads not only on ground roads but also on water roads, and also we need to introduce more different kind of transport, including water transport as well. And therefore, first thing we need to do, we need to extend road into water road class, which is almost the same, except its type is more specific. And you will see this also for exceptions and other thing, because Java is strongly typed language, you can tell quite a lot of information just by type of an object. In this case, we are not changing anything in already working class, which is called road, but to say that this is actually water road, we say this information using its type. So we need to create new class in package GTM activity 05. And superclass here in this creation wizard is not Java object, but it is road from package 04. And if we do so, import of this package is done automatically. And then, because constructors are not inherited, we need to create these constructors, and we are actually very happy just to use constructors from superclass. What is wrong here? From superclass. So what what is needed is both constructors, road without parameters and road with string int, and that's it. And because we don't need anything else, we can remove this to do, because that's what we need. And how it works: when water road is created without parameters, water road with empty from to and 0 length distance is created, and water road with following strings is created. Then we actually call constructor from superclass, and we put required values into these fields of this object. And I think that part is done, but then we need override to string method. And again, we can write everything by our poor hands, but we can override in this case to string method. And what should be different in that method is that it returns water road. How we implemented this? It shows only this, so that means we need to return. We can write something like water road plus super dot to string, and remember that when we talk about constructors we write super and opening brackets directly. When we talk about member fields or member methods we write super and dot. If you don't remember exactly, you can always just write this and do auto completion, either open bracket or dot, to see what this auto completion provides for us. But if you want to be future proof, you can do something like this as well. Get class, which will get reference to the class, and then get name for this class. And this is more complicated in this particular case, but then we have created a virtual method here. If actual specific type will be different, for example water road will be extended to something more complicated later, then of course we will get different name here for different class. And then I don't know how JUnit test works for this package. This is strange. This test for some reason is left here in this place, and it will run for Eclipse and IntelliJ IDEA, and we have not created all classes yet, so ship class is not created, etc. But particularly for simpler tools like NetBeans, which follow guidelines more strictly, you will not be able to run this test in IntelliJ IDEA, because this test actually should be located in test folder, not main folder. But if everybody is using either Eclipse or IntelliJ IDEA, this shouldn't be a problem. Actually, previously for previous bootcampers everything was put here, but it doesn't follow Maven standards properly, and that was one of the reasons why previously I didn't even try to use NetBeans, because this project didn't work on NetBeans. But when I find out that only problem is not following Maven rules and standards, so for you particularly this project was a little bit reorganized. Yeah, so don't be confused here. Package for this test is absolutely the same, gtm.activity05. As I told you, actual files and folders, location of file inside folder is related to the package, but it's only a relation, And actual place depends on configuration, and one thing for configuration for Maven project is what is it considered a main class which should be packaged and shipped to the customer, or is it considered a test class which is not packaged and shipped to the customer, so in different folder. So physical location either in main folder or test folder is not so important, but name of package is important. And for more complicated projects you can configure it that your source actually is also located in different folders. So next thing we need to create is ship. And creation of the ship classes also should be easy. We create new class in activity05 package, but we do not extend object, we extend transport. And here you see how important it is to have globally unique class path, because we have two different transport packages, transport in Sun RMI transport package and transport in GTM activity04 package. And of course we want to extend this transport, not that transport. And here my creation wizard got immediate compilation problem because it didn't add constructor. Because what is happening here, when you generate some code, quality of generated code of course depends on quality of source code generator. And if this generator creates such class without a body, implicitly it means that I have created constructor ship which doesn't take any parameters, which call super, which also doesn't have any parameters. And problem is this referring to the super, because for transport in this package there is no constructor without any parameters. Only constructor for transport is constructor which takes three parameters: string, float and int. And this code and that code is absolutely the same. Only code is smaller, but how it will compile and how it will work is with such explicit constructor. And of course we can just add some arguments here to make compiler more happy. And here we need to also where's the string? And now it compiles. Other thing is we create constructor, but this again is generated code which is compiling, but it doesn't mean that it does what we need, because what we need is that for ship there should be constructor these following parameters. And when we look on transport, we see that it has field to store value for identifier, ID, consumption tank, say full and tank. But for ship we also need to remember additional complexity in files. And then when we implement, for example, constructor, note that fuel is not used when ship is moving because it uses wind for sailing. So here for consumption we can say 0, tank size 0, just to make compiler happy and to pass necessary arguments to the inherited and referring using super keyword to the transport constructor here. And then of course we need to say that remember passed parameters of sale. So ID will be set up and inherited by transport class, and sales will be set up here. And to visualize it, let's say 1, let's say 3 sales. And what happens when we have created this ship object? We inherit ID, fuel in tank consumption and tank size from the transport object, but sales is new added complexity here. And when we execute it, our data structures look following: inherited data structures and added data structure for this particular thing. And if we will upcast this ship to the transport, then we still see, because it's not encapsulated. Do we need to say something about number of sales? Okay, for sake of visualization, if I make this number of sales private and I look on this as a property, now it just looks that it is private, but still shows it up. So that's about these data structures. Now we need to it is used, why it has such warning. So we need to override move method, and again we can try to generate some code for it, generate or override implement method and move. And what we need to do, we need to check that so we need to check if row ID ship is this get type, super get type is sailing on, road as a string representation. These as sales. And maybe I don't need to write super because get type, yeah, it is inherited. We can write it in the following way. And else return what we need to return. Cannot sail on. And again, this is not tested, so some bugs may be hiding here, but this looks at least implemented for first iteration for me. Then we need to create similar class vehicle. Which also extends transport from package GTM activity 04. Again, I get compilation error because implicitly this means that again it has constructor without body, and without body this means that it has, so this code is the same as this code is the same as this code, because there is no constructor for transport object which doesn't take parameters. We need to do something like this, because if you call super, and of course you can create constructor like this. And what are requirements for vehicle? As usual, here it says it needs to be protected, not private, so something is not. So we need to make this protected, and we need to make such data structure for vehicle, and proper parameters for this is this one, and then similarly to the ship we need to remember what number of wheels were passed for this vehicle. So that's about constructor, and then we need override move method. Override move. So this is one case, and another is this. So here again we need to check the size type, and we can do it in opposite direction if crowd But problem with such approach is that it will work for this current design, but it is not future-proof, because there may be other types of roads introduced. One thing what I can easily imagine is road by air for airplanes, and therefore checking for specific other type is not good. But here we have problem that road is more general type, and if I will say if road is instance of road, it will always return true, because any other subtype will also be road. And therefore, to make it more future proof, I will do it a little bit different. I will check for exact specific type of this road. So by getClass method, I get this reference to the definition of the class to which class this object belongs, and it returns direct reference to the class, not says it's all the road or subtype of road. And then, of course, getClass returns me a complicated data structure called class, or definition of the class. But as I told you, you can always, any data structure, you can implicitly convert to primitive type if you use operators. And operators work only with primitive types in Java. And what I'm doing here with such operator, and I don't know how it will work, but it will work absolutely the same, I think, only it is more complicated. So get class and check that this reference to the class is the same as the definition of the road class. And road class property also returns its type. So choose whatever you like. If you think more formal approach is used, use equals method. If you are practitioner like me, then you can use something like this. And then what we need to do, we still need to use fuel and other these things, and therefore we should refer to already implemented method here where we did all these complicated calculations, and therefore we could do something like return super move road with but then we have different problem, because this move method says blah 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 is moving on, but we need to say here is driving on. So that's one problem. So just simple string concatenation is not everything we need. Other problem is what will happen if there will not be enough UL, and if there will not be enough UL, we will get string. Okay, I can visualize it again. Parameters. shouldn't be enough. Consumption per consumption per 100 kilometers. Okay, something like this. So that cannot move from blah 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 necessary fuel flow and then with blah 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 wheels. So this is not good, and therefore instead of just return super, we actually need to do something like this: string status. We need to check how exactly it moved, and then if contains, let's say, moving, we need to do many things here. Something like this. And okay, cannot drive on. There is missing spice here. This is my own string. And if there is enough fuel, looks like works to me. And then, so this implementation is a little bit more future proof, because if there will be any other subtype of the road, like air road or air road or whatever, which extends road, it still will say cannot drive on it, because any other type which is not concrete road class will be handled in this other option. So I think such implementation is more future proof. And then we need to create amphibia. Class which also extends this kind of transport. And again, this code generator creates code with a compilation error because of this implicit constructor, which doesn't work. Because what is working is something like this. And then we need to override move method. In some way. And here we have different options how to implement it. From business perspective, we see that this is typical multiple inheritance, that amphibia is some kind of transport, but move works in a such way that it looks like a vehicle on ground road or this precise standard road, and like a ship on water road. And we cannot say that it extends. For ship, that would be very nice, but it's not allowed. So one thing we can do is following. We just blindly do implement multiple inheritance as composition. Does anybody want to ask something? Vladimir, do you want to ask something, or just you switch it on by accident? And then we do something like this. What do we need to pass for ship? We need to pass ID sales. And for vehicle we need to pass and then we do something like this. And let's run JUnit test. And first, something is not great with implementation of design for amphibia. String float int byte int. String float int byte int. What is missing here is public. Then what is wrong for water road? We need just simple name for water road. Get instead of get name, get simple name. And then we have problems with encapsulation. We are required to make every dirty details of implementation private. And now it almost works, except amphibia fuel error. Where does it comes from? It comes from here. So when I go into it and I return to move, here is what internal data structure for my amphibia looks like. I have consumption, fuel in tank, ID, tank size, and these data structures are inherited from transport. Then I have consumption, fuel in tank, ID, sales tank size inside ship part and inside vehicle part. So I have 3 IDs, 3 consumptions, 3 fuel in tanks, etc. And of course everything almost works, except that here, if I just use road vehicle part for move inside vehicle, fuel in tank now is decreased, but fuel in tank, which is inherited from transport directly, it's not decreased. So we can just patch it by ourselves. And after this move, before we return it, we do something like set fuel in tank is get fuel in tank. And now when we run it, let's run it again. So step into this. Fuel in tank is decreased, so what we have inherited from transport now is updated with what actually happened in this vehicle part here. And if we are brave and we try to run JUnit tests, so now I have too little fuel in tank. Why it is so? The consumption. That's what's wrong. Instead of wheels, when we refer to transport, it should be ID, consumption, and tank size. So this is wrong past parameter to it. That is right. And here we need to pass like type. For example, here amphibia mole status, let's say replace what is what? Expected amphibia. So vehicle with amphibia. And here, ship move road, replace ship to and now it even works. And if you don't care about proper implementation but only about credit point, then you can assume this is done. What is not done here is that you have severe case of duplicated redundant data structures, because now in this amphibia here we have three identifiers, three tanks, several places where consumption is set, etc. So let's show here what do we have here. So we have consumption, fuel in tank, tank size, ID. Then inside of ship we have consumption, fuel in tank, also sales, tank size. And this is very bad approach, because such system will be very hard to maintain in future. And because of these triplicated data structures, it means we have approximately 3 times more disk space needed to maintain many amphibians in our system. And if you think 3 times is not too much, 3 times means that if your disk is 30% full, you can easily work with your system and maintain it without many headaches. If your disk is 100% full, which is just 3 times more, probability is very big that nothing will work. And therefore, this is very big sin to do, that you have duplicated data structures. And when you do encapsulation, you should remember this rule that you shouldn't have duplicated data structures. And for example, if we need to create some human here, we are allowed to create human from parts, like we take one head, we take one body, we take 2 arms, and we take 2 legs. So this would be one part. Okay, I will show it in 3 different colors. So we can take head as one part, we can take body as another part, we can take arms as another part, and we can take legs as another part. And so all these 1, 2, 3, 4, whatever they have, different parts create normal human body together. So this is proper composition. But we have very improper composition, because we have, this would be, let's say, our transport part. Then, okay, this would be transport. Then we have ship part. And then we have vehicle part. And of course, everybody who can count will say that this is not proper human created with different parts. And so every time you create such a Frankenstein monster with duplicated parts, you are doing it very wrong. And that means that here our simple approach to do composition, and of course we can make everything else private, that these other heads and unneeded parts are not visible. So this is not visible, that is not visible, and so everything looks more or less okay from outside world, but internally such duplicated data structures are very bad. And what can we do about this? Also, you need to remember that duplicated data structures are always bigger sin than duplicated code, because if you have duplicated code, probably you have 1, 2, 3, 7, 15 different classes, and if you will have some duplication, you will have some duplication in 2, 3, 7, 17 cases. If you have duplicated data structures, you will have duplicated data structures in 1,000, 20,000 to 1,000,000 cases, whatever how many objects you will have. And therefore, when you need to deal with tricky cases, you need to follow this idea that it's more important to have clean data structures than to have so clean code. Of course, you need to follow this goal to get clean code as well, but if you need to decide, then data structures always should be more important things than your code. And to get rid of this, you should do something like that. You still extend transport, but instead of these improper parts which overlap and make duplicates, you add only needed parts, like sales here, and like bills here. And now we will have much more proper data structures. And so here, instead of these duplicates, we say that this sales inside and this else. And then we now refer to the transport, and for move method for ship we will have less sin here. We will return and maybe this will work as well. So we need replace transport with amphibia. Moving with driving. And plus what do we have here? For vehicle. So we don't see it anymore. Something like this maybe will work. And now, if we look it into debug mode for our main method in this test here, we don't need this anymore because we rely on properties inherited for transport. So this may be removed. And now we do not have any duplicated data structures at all, and this is much more important. And again, if you care about data structures and credit points, we have done this work again, but in much more cleaner way, because now our Frankenstein monster, instead of this bad one, now we have this proper one. We added, let's say this is the sales part, what was needed, and this is this wheels part. So we have properly created our amphibia. But if you also want to get shorter code, you may see here that what we have done here is quite a lot of what we have done here, this second part, if it's not water road, which is actually coming from vehicle. And what we can do here is that amphibia extends transport, this means it is transport, but if amphibia extends vehicle, it still is transport, but we can get rid of these wheels here, because then we will inherit wheels from transport, from vehicle. And here we need wheels. We get rid of this part, and we get rid of this part as well. All we need to replace vehicle with amphibia. And then we, I think, can just actually say return. And it still works, but data structures are much shorter, and code is also much shorter. There are different ways to implement it, but what we have done here is following. We had this diamond problem, that we have transport, which is extended to vehicle and ship. And here I'm writing sloppy class diagram. So this is extended and that is extended. And for amphibia, first we liked symmetry and we extended it to transport and added missing parts like wheels. And so here we have additional wheels. Here we have additional sails. And of course we have move method, but I ignore that for now. And we added wheels and sails here. But if I do not follow symmetry, but extend it to this place, I immediately inherit wheels, so I don't need this one. And because I can extend only one, I add missing parts. This is ship and code for move method. And you shouldn't follow some strange beauty standards. For example, in fundamental physics, they have a big problem because of following these beauty standards, how it looks like world is working. You should follow this cohesion and high cohesion, low coupling principles. This means nicely related things when they are need to be related and not related when they don't need to be related, to create your designs and just something like nicely symmetric UML class diagram when you show your design. There are some other options how you can implement it, but I can bet that in general your code will not be shorter than this implementation. And of course, if we delete this test method, main method which we used for our manual API tests, so these three classes look following: ship, transport, vehicle, and amphibia. And in this stage of implementation, we can finally say that it is more or less okay from data structure perspective and also from design or code complexity perspective. You can do it a little bit differently using static methods and passing parameters of these to other. But when I have tested it out, I saw that total complexity is approximately the same. You can implement it a little bit differently. Some methods will be simpler, some methods will be more complicated. But this is something what is closest to ideal in this not very ideal situation. So that's about this exercise. Do you have any questions or comments on this?